128 bits, right? And this and after each stage, the data block is referred to as a state. Okay. So how this works, I will explain you with the help of an example. Right. So this is what this is my key. Key is of 128 bits. That's my Kung Fu. So ASCII characters we have written. First, we will see how the key is generated in each round. Okay. First, we will see the key generation. Then we will see how the different stages in each round performs. Right. So the key we translated into hex. We have written it into hex. This key, and then the plain text is given as 2192. So this is also written in hex. Okay, so this is our plain text. So you can see that this is an space, so it is represented with 20 hex. Hex mein space or blank is called as 20. Otherwise, they are represented in hex. Okay, ASCII characters. So we will see how the round keys are generated. So I told you that in each round there is a 128-bit key is to be used if we consider that the number of rounds are 10, right? So for 128-bit key, there are 432-bit words are to be used, right? That will be in round 0, W0, W1, W2, and W3. So that is nothing but this key. So once I divide this key, okay, into 432-bit words, you can see here. This is what W0, W1, W1, then W2, and W3. Okay, so 432-bit words. So 128-bit key is written in 432-bit words. So W0, 54, 68, 71, 61, 74. Then there's W2, W2. So this is the key. So I have just written in the W0, W1, W2, W3, right? And this is the round key for round 0. Okay, that is just round 0. And then for round 1, we have to generate the key. So how we will generate the key? From the new key will be generated from this key. For the next round, the key will be generated from this only. So how we will generate it? So there are some fixed operation. Okay, we perform a circular left shift of W3, okay, by 1. So this is all fixed. Okay, so we get it, this 20, 46, we once shifted left, and this is what a byte substitution. So byte substitution is performed like as you can see that in hex, this is in hex. So I have these two numbers, okay, 2 digits. So this leftmost says about the row, and this rightmost says about a column. So this is what nothing but a substitution method. So already we have some fixed substitution bytes. So this will say that in a matrix, in a matrix of substitution bytes, okay, this will be like I can show you. So this is, I think you can see that this is a sub-byte transformation table like this. Okay, this is inverse byte transformation table. So here, this number will say that this is the column, which column, this is which row. So like that, a number given like this. Okay, this will say which column, which row, and then from the table, this will be substituted in this table, right? So this is how the substitution. So you can assume that this is a pre-planned thing, okay, predetermined. Already we have some table that this particular byte will be substituted with this, right? So that just like we did in DES, we had seen. So here This is a predetermined, from the predetermined table, we substitute this. So while substituting this digit says about a column, this digit says about a row. Sorry, 2 says about a row and 0 says about a column. So where exactly it goes, right? Which byte it will be substituted. Then this round constants are fixed. For each round, these round constants are fixed. For round 1, this is this. For round 2, also I think the same thing. Then round 3, round 4. For every round, this is also fixed. You can see here. Okay, for each round, this is fixed. Okay, like that. So 1, 2, 3, 4, 5, 10, 1, 2, 1, 2, 4, 8, 10, 20, 60, 80, 1B, 36. So for each round, this leftmost byte is 1, 2, 4, 8, 10, okay, 20, 40, 80, 1B, 36. And these three bytes will be 0, right? So adding round constant, so we add this round constant as 1, making this shift by 1, so that is B6, okay, 5A, 9D, 85, right? And then we generate W4. So W4 is nothing but GW3, which we perform some operation on W3, right? And got this GW3.
So how is the adding happening?
Which adding?
So this adding round constant, we are adding it to 20, right? It will be 21 and finding it again on the table.
We are not adding on 20. 20 is substituted on this 20. A byte substitution is performed through a substitution box, right?
Okay, sir. Yes,
so after that, you got this after byte substitution, and then on depending on the round, which round you are talking, this round constant is added. Okay, so this round constant operation is performed on this, and then W4 is generated. That is nothing but W0 XORed with GW3. Okay, so you get.
Did we get GW3 B6, B7 plus 01 B6?
Actually, it is mixed. We basically mixed it, right? You can say that we are just changing it by one number, okay, 4 number, 8 number, like that. So mixing is done here. Okay, so I will elaborate that process, how the mixing is done, how it is changed to B6. Okay, I'll change it. I'll just explain it. Okay, so once this is done, W4 will be the round key for the next round. That will be W4 to W7, 4, 5, 6, 7 will be generated. W0 XOR with GW3. So once you do XOR with this, you got this E2, 32, FC, F1. That is after XOR operation with W0, you got this. So this is W4. Similarly, W5 will be W4 word 4 plus XOR with W1. Right? So you got this. Just like an XOR operation will be performed, you get this. Similarly, W6 will be W5 plus W2 XOR with W2. So this you will get. Similarly, W7 will be W6 XOR with W3 word 3. Then you got this. So you got the round keys for the round 2, W4 to W7. For round 3, it will be W8 to 11, right? So like that, we can generate it. Once again, you can perform the similar type of things where the round constant will change and this byte substitution will differ. Again, for the next round, you can generate it. So like that, if you do, okay, you generate, this was the round 0, which was the actual key, 54, 68, this one, okay. Then round 1 key you have generated E232FC using this. Okay, so when you are going to generate W8, so W8 will be equal to W4 XORed with W7, GW7, right? So then W9 will be W8 XORed with W5, right? Then W10 will be W9 XORed with W6. So like that you will get the key for the round 3, right? So we will generate the key for each round based on this approach, right? So considering 10 rounds, 128-bit key, because if we go for 12 rounds, the key size will be 192. Going for 14 rounds, the key size will be 256 bits, right? Now this is about the key generation. Now coming to this AES process, how this add round key, substitution byte, shift rows, mix column, add round key. Okay, so state matrix round key. So we have written this 54, 77, 6F20. This is what your plain text. This is what your plain text 54, 77, 6F20, 4F6E. So this is written in the matrix form here. 54, 77, 6F20, 4F6E, 65, 20. So this is what your plain text, right? This is what your plain text coming from here. And what we are doing, we are adding the round key with this. So what is my round key for round 0? Round 0, my round key is 54, 68, 61, 74. So this is written. So how do we generate? What we do, we perform the XOR operation of the corresponding entries. So like you can see that 69 is XORed with 4B. So that is 22. So we got a new matrix, state matrix. It is called after each stage, the output is called as a state. So we got a new matrix. After that, then we will perform the substitution byte. So this is the current state matrix. Then substitute each entry of current state matrix by corresponding entry in AES S box. So this S box substitution box is fixed, right? So just that is just like a predefined procedure where you will be substituting one byte with another one. So byte 6E, let us say, will be substituted by entry of S box in row 6. As I was telling you, row 6, column E by 9F. So this S box will be there at one place, right? So from that box, you will pick up based on the entry, because this is a 2-digit number, so that can identify a row and a column. And from there, it will say the position of the byte which is to be replaced with another byte that is from the S box. So that will give you this. So a new state matrix is got it, right? So you can see that this operation is over, then substitution bytes is over, then shift rows, right? Shift rows. So you will find all operations in AES are invertible in each round, right? So this is so this was the current matrix that you got it after this substitution. Then, so depending on the round, right, which round you are there, it is well defined that how many shifts will be there. Cyclical shift will be there to left of 0, 1, 2, and 3. So you will find that. So round 0, nothing will be changed. This is 4 rows are shifted cyclically to the left by offset. So row 0 there will be no change. This will be shifted by 1. This will be shifted by 1 left side. Okay. This will be shifted by 1. This will be shifted by 2. This will be shifted by 3. Okay. So we got this. So this basically causes diffusion of the bits over multiple rounds, right? So cryptanalysis attack and other things can be avoided. Then shift row, then mixed columns. So mixed column, basically how do we perform? We multiply a column, this column with a constant, okay, and then we put it. So mixed column multiplies fixed matrix against current state matrix. So so this is what we got, this matrix, current state matrix, and this is what a fixed matrix, or you can say a constant matrix. Okay, so we multiply each column with that and generate a new matrix. So it's a matrix multiplication. This matrix is fixed, and this is what we have obtained from the previous stage, right? So like that, how the matrix multiplication is performed. The VA is basically the result of 2 into 63 plus 3 into 2F. So each column, okay, each column is multiplied with this. So you got the new values. You got a new matrix. This is how the first round is completed. Then again, when the round 1 is over, okay, you enter into the second round. Second round, again you have to add round key with this. So W4 to W7 will come. Okay. So there, what is the round 1 key? E232 FC F191. So this will come. So you can see E232 FC F1. This has come. This is the key for round 1. This is what you have got from the previous round. This is the state of the first round. Okay. So again, the same thing will happen. XOR, then AES output will come after round 1. Then like that, substitution byte, then mixed columns, round key, like that, round 3, round 4. Similar way it will go on, right? So and when you go to this side, decryption side, it is just an inverse of it, right? So the ciphertext goes, we start from the reverse side, the other side of the rounds key. So this key will be used because it's a symmetric encryption. The same key should be used. So the same key is used over here. Okay, when the ciphertext is given to decrypt it, and it is followed over here. Okay, the same keys. So here in AES, there are multiple states in each round. The output of each stage is called as a state, right? So that is what it is shown over here. Okay, this. Any doubt?
Understood.
Okay, so let us move to. So we have finished the symmetric encryption. Okay, symmetric encryption uses the same key. So if you compare AES and DES, first of all, there is a difference in the key size. The block size is different. AES is more powerful. It is equivalent to triple DES, which is very slow because of the three DES algorithms are used together, right? So and DES was broken. So and AES is more powerful, and it is we use it. Still, we use it. Right? It is very well, very much in use for the symmetric encryption. So as you know that encryption allows us to protect our data, okay, from misuse. But the question arises, okay, it somehow counters the threats to network security, but there is a question arises that where to encrypt and what to encrypt and where to encrypt. So this question is very important when we say about as a network security, right? So if you just see here, this is a these end users are connected through a X.2 pipe packet switching networks. Okay, so these are the packet switching nodes, right? So there are two possibilities of encryption, right? Two possibilities of encryption is either we encrypt the link. So you can see that this blue this thing shows the link is encrypted. Okay, this link is encrypted. The whole link is encrypted. Link to link encryption. There are two possibilities. There is a link to link encryption or end to end encryption. See, I told you that the question is that what to encrypt and where to encrypt. Like suppose in a data, which part of the data should be encrypted? The entire packet should be encrypted or some portion of the packet should be encrypted, and where exactly the encryption should be performed, right? So there are two possibilities. One is a link-to-link encryption and another is an end-to-end encryption. So if I say about link-to-link encryption, right, data is generated from this end user. Okay, so this link is encrypted. My data travels. So since the so all the traffic over all communication links are secured in all the links are encrypted. First of all, what is the disadvantage of this scheme? Can you see and say, tell what is the disadvantage? You can directly find it out. What is the disadvantage of link to link encryption?
सर अगर लिंक फेल हो गया तो नहीं होगा encryption.
Link तो वो अलग चीज है, फेल हो गया, that's a different thing. Then the whole communication will. First of all, you require large number of encryption devices for link to link encryption. Okay, large number of encryption devices for encryption, and when your data enters into this public packet switching node, which is public, right, your header part needs to be opened, because if otherwise how will it decide that where it should forward, on which link the packet should be forwarded? So for that it has to open the packet and see the header part. So this with link to link encryption, if I am talking only about the link to link encryption, this link is secured. Here the attacker cannot get access to this, but the moment your data enters into this packet switching node, where your packet has to be opened, for the header part needs to be opened, right? Then it is vulnerable here at each packet switching node, right? So what is the disadvantage of link to link encryption? That the large number of encryption devices are required. Secondly, that the data has to be opened, the packet has to be opened at each packet switching node. Then only the packet header will be known to the router, and then only the router will perform the routing, right? So it needs to be decrypted each time Okay, it enters a packet switch node, and then your data will be in open, in transparent, and it is vulnerable because virtual circuit number is to be seen. So if I say link encryption, each communication link equipped at both ends. You can see each communication link is encrypted at both ends. All traffic is secured. High level of security requires lot of encryption devices. Message must be decrypted at each switch, packet switching node, to decrypt address, to read the address or the virtual circuit number. Security is vulnerable at switches, particularly on public switch network, right? But if I say about an end-to-end encryption, so suppose if this device has encrypted it here, this black one, and only the destination can open decrypt it. Okay, with end-to-end encryption, the number of encryption devices are less. So what is the disadvantage of this scheme?
So in this case also the intermediate nodes will have to open the gates to know the address.
See, that is not the case because that is also to use both link and end-to-end. So the header part will be encrypted using a link-to-link encryption, and the data part will be encrypted using end-to-end encryption. Now, since we are about to end this symmetric key encryption, the main challenge in symmetric key, as you know, that the distribution of the key. Both source and destination possess the same key for encryption and decryption. So the key distribution is required. So the same key is to be used. Okay, the key distribution is required, and if we are distributing the key, we need to protect it from the attacker. And as the bank advises you that you should keep changing your password frequently, right? क्यों बोलता है कि if somebody has got a guess that what exactly you are using, it can be broken. Okay, so you should keep changing the password. You should not keep any thing which is known in public, like your birth date or something which is flashing on Facebook or any public domain. You should avoid keeping such passwords, right? So key distribution is a vital point here. So what is the possibilities of key distribution? So there are 4 possibilities. Key selected by A and delivered to B. A will select the key and will go and deliver it to B, right? The second solution is third party selects key and delivers to A and B. So like the first two are manual approach, like you lock your room, you go and deliver the key to your friend. And in the second case, it is like you lock your room, you give your key to the third friend, and then that friend goes and delivers the key to your friend. Okay, so like that, these two approaches are manual approaches. If for link-to-link encryption we are talking, it is to some extent it is okay. But when we are saying about an end-to-end encryption, and that too in a network like in a wide area network, this to manual delivery is not possible, right? Manual delivery will not be possible in that case when you are talking about a wide area network, because the two end users may be far apart, so manual delivery is not possible. So the first two options are not suitable. The third option says that use old key to encrypt and transmit new key from A to B.